All right. So I'm gonna go and share this week's module because we have exam and there are a lot of questions. So we're gonna take care of those first and then continue. I'm going to talk about same thing as exam one, a review of exam two on Wednesday and Friday in person. If you already scheduled with SLDS, I will upload the exam with them before Friday. And then same as exam one. I'm not planning to give you like a quiz thing I gave you for conceptual. That was just so you know what kind of conceptual question I will ask. So similar thing will appear in exam two as well. Now, here you can see information regarding exam two. You can bring your cheat sheet for exam one, the same thing you wrote. You probably don't need it, but if it improves your confidence, by all means. So no, same thing, no solve the example or anything. For exam two, same deal. You could use behind that paper and write your exam two cheat sheet. So you can use that for final exam. Or you could bring another page that only one side of it is your cheat sheet. You turn both of them in, all right? Same deal, write by hand. If you're an iPad user, write by hand and you can print it on a page. The reason is I don't want you to copy paste from the lecture last minute. So the whole idea is you study and prepare your cheat sheet. So whatever we left off from exam two would be covered from exam one would be covered in exam two until the end of PID controller, which is all the material that came in your homework 4, right? So you even use MATLAB toolbox. So you might see a question, I'm asking a question about MATLAB. Just making sure you know what you were doing, all right? So expect those kind of questions. Again, this is a 55-minute examining class. I'm not gonna ask you to write a code, but I might test your knowledge on some of the commands, right? All the material will be from the lectures, I think lecture 12 to 24, all your CPs between now and then, well, between now and last week, then and last week, and homework 3 and 4, okay? Study, and I think now you know the kind of question I ask, so I feel like you'll be more prepared for exam 2, so my hopes are higher for exam 2. Hopefully you'll have better grades. Office hours, the usual, we have our office hours, so you can either come for homework 4 or for your exam. Thursday, I'm pretty busy at capstone. I don't know if you have extra time. Do you have office hours on Thursday? So office hours on Thursday right before your exam. So if you have questions, you can go to bed. All right. If you email me, because I'm very busy this week, I might not answer. We have our EC candidates coming in, so we have to be in an interview with them all day. So I'm right now not there, I'm here. But I might not answer emails as quickly as I'm used to. So if you have a question regarding exam or anything, email him, CC me, so I know you asked a question, but you're not expecting me to answer. All right. So housekeepings, no mobile. You should be using the exam. Bring your calculator. You probably need it to calculate poles and zeros, right? Those kind of calculation. And you have natural frequency and all of those for second order differential equation, right? So you might use your calculator. That's all I thought I should talk about exam 2. Any questions about exam 2 specifically? Clear? All right. So let's get back to our lecture. So we ended up covering 7 rules out of 8 of root locus. Now, if you go online, there are different, like there's another 7 rules, but the rules are different. Everybody that writes those instructions, they give number of rules, and then so the rules don't match. So I was just pulling up like instruction for root locus from some of the online instructions, and then their rule 7 was different from mine. So don't be hooked up, oh, your rule 7 does not match the book, or like this person A or person B. All the information to draw a root locus is the same. Okay, it's just organized differently. I organize based on amount of work needed to be done. So rule 8 has the most work to be done. For your class participation, you just needed to find the number of Lockies. You're going to finish that today. So that would be your class participation for today. The other two that was read. So here are the first 7 rules just for your information if you want to use it. Now, rule 8 talks about, I'm recording, right? Yes. Rule 8 talks about asymptote. So when you remember that if you don't have enough poles or zeros, right? If you don't have the equal number of poles and zeros, some of them are in infinity. Either, so you always go from pole to 0. So either the 0 is in infinity or the pole is in infinity comes to your S domain, right? Now these always come along an asymptote. So asymptote are only for those poles and 0 that part of their pair is in infinity, okay? Now, we need 2 information. One is the angle of our asymptote, and the other is where does the asymptote start or the centroid of asymptote. If we have multiple asymptote, do they intersect? And then where is that point? All right, so the first one is easier. The angle of the asymptote, you basically follow an equation. Both of them have equation. I think the first one is more straightforward. The angle of the asymptote, phi of A, depending on how many you have, A1, A2, A3, is 2 times Q plus 1 divided by N minus M times 180 degrees. So things that we might not know here. Q, what is Q? What is N and M? N is the number of poles. M is the number of zeros. Okay, so we know these pretty quickly as soon as we look at our equation. 180 degrees is basically the angle is measured from the right side of your real axis towards the left side. All right. Q starts from 0, goes all the way to N minus M minus 1. Now, M is number of poles, M is number of zeros, and then minus 1. What does it mean? So let's say that we have N equal to 1, M equal to 0. This means our system only has 1 pole, right? Now, calculating Q would be N minus M minus 1. So it's 1 minus 0 minus 1 is 0. So it means that Q is equal to 0. Now, if this was, let's say, if N was 2, Q would have been 2 minus M minus 1. So let's say, so this would be 2 minus 0 minus 1. So you had 1. This means Q is 0 and 1, right? We always start from zeros. 0, 1, 2, 3. All right, so don't forget, if you got 1, it's not Q is equal to 1. It's 0 and 1. One way to check this is, since we are talking about number of asymptote, we can check how many Lockies we have, right? And then check if we have the same number of asymptote for them. Not all the Lockies will go to infinity, but it's a good way of checking. So you don't get more Lockies, more asymptote than Lockies that you should have. So if we have N equal to 2 and M equal to 0, how many Lockies we will have on a root locus? Maximum of 2, right? So we'll have 2. Now, one of them might go to infinity, both of them might go to infinity. All right. So if Q is 0 and 1, means that both of them are going to infinity or coming from infinity. Okay, because we will have 2 asymptotes. So that's for the number Q. Now, to find the angle, you just plug in all the values there and then find your asymptote. Now, let's do that for this first example that I solved. Again, right now, it doesn't matter where your poles are, right? We're just talking about the number of asymptotes and the angle that the asymptote builds with the real axis. So let's say I have one pole somewhere here. I don't have any zeros, right? So from all the rules, rule 1 to 7, I know the lock, I have one lock key, right? The lock key has to go from pole to 0. The lock key will be on the left side of the odd number of the poles and zeros. Here we have 1, so it's going to be on the left, right? We don't have any zeros in there, so it has to be an infinity. Remember? Now we can have one extra information. What is phi of A? We found Q is 0, so 2 times 0 plus 1, 2 minus 1, no, 1 minus 1, sorry. 1 negative 1 times 180 degrees. So phi of A here is 1 over 1 times 180 degrees. So our asymptote is going to build 180 degrees with the real axis. So asymptote is this, right? So this means that the lock key will go alongside this asymptote to the infinity. We also knew our 0 is an infinity. So it's going to find its soulmate. It's going to infinity along this. All of them match, right? So we didn't need this angle for this one here because it's very straightforward. You already know if it's on the real axis, if the pole is on the real axis, you don't have any 0, it has to go that way. But finding this angle kind of ensures you that you're correct. Does this make sense? Yes. So you might have different variation. Whenever we are dealing with asymptote, we have to think a little bit how this would look like. All right, we can't just draw because our goal is to use MATLAB. So I'm not teaching you all the rules for drawing root locus, just teaching you very basic ones. All right, so this was the angle of the asymptote. Now for the centroid. So sometimes you have more than one asymptote and you want to know like if they are crossing each other or where do you start that asymptote? Again, asymptote is an invisible line, right? But sometimes it's important where that invisible line starts or meets or intersects. So the centroid will be following this equation. Sigma A is the summation of finite poles minus summation of finite zeros divided by n minus m. N being the number of poles, m being the number of zeros. Yes.
If the angle instead of being 180 was 90 or 270, would the asymptote be going up or down?
Yeah.
Okay.
We have examples of that. Don't worry. Yes, you basically follow that. Draw the angle, draw that line. Yes. For n minus m, 1, 0, 1 pole. So if you have 1, 0, 1 pole, can someone answer his question? No, can't. So think of your example. I want him to answer. I want him to arrive to the conclusion. So when do we have asymptote? We are missing a pole or a 0 inside the S domain, right? If the number of pole and 0 are equal, n minus m is equal, so that the denominator is 0, means that for every pole we have a 0 in there. So we won't need an asymptote. So we won't get here. So you will not need asymptote for every single transfer function to draw the root locus. Very good question. So you found that because this would not make sense, right? But it's because if you have 1 pole and 1, 0, which is this situation, done. You don't need an asymptote, right? Q cannot be negative. It has to be 0. But you can say 270 is equal to negative 90 because in the angles is the same thing. I saw another hand. No? Okay. So now what is finite pole and finite 0? Not infinity, right? So if you know like there might be a 0 in infinity, since we don't know what it is, we don't count it. We only count the one that we can calculate them. Conjugate pairs are also finite. They're just different looking. All right. Yes. Yes. It's always 4 times 180. So for the centroid, now let's work on an example. let's say n is equal to 2, m is equal to 0. So if I write m capital or lowercase, they both mean number of zeros. Now, let's say s poles is as -1 and -2, because for centroid, we need to know the value of our pole and 0. Now, the centroid is going to be -1 plus -2, number of poles, minus zeros is nothing, 0. 2 minus 0. So it's -3 divided by 2, -1.5. So that is the centroid. Let's draw the root locus for this example. All right. First of all, how many Locus do you have? 2, because the number of pole and 0, whichever is greater, right? Or n minus m. So the number, no, not n minus m, whichever is great. So 1 is a -2, -1. 1 is a -2. There's no 0. So I know these two both will go to infinity, right? So I expect to have 2 asymptotes. Now let's go find the q's and the angle of the asymptote. So you don't always find the asymptote. You put your poles and try and then see if you need an asymptote. If yes, we go to centroid and the other one. So let's find the angle of our asymptotes. So phi1, so let's calculate the q. Q is n minus m minus 1, 2, 0, -1 is 1. So Q is 0, Q is 1. So phi A1, so the first angle is going to be 2 times 0 plus 1 divided by 2 minus 0, like 180 degrees. So 0, 1 times 180 degree, 90 degree, set. That's what you just asked, right? So one of them is 90 degree. Then phi A2 is 2 times 1 plus 1 divided by 2 times 180. This is going to be 270 degrees. So I'm gonna bring this guy over here just because I don't want it to, I want that part to be clean. So I know that I have 2 Locus, I need 2 Locus. Both of them need to have asymptotes, right? So I'm gonna draw my asymptote with orange here. First of all, I have 2 asymptotes. Where do I put them, right? That's where the centroid will come in handy. So sometimes, well, you have to look, you might find, well, actually for centroid, you always find one number, never mind. So here would be -1.5. So you know that the asymptote will pass through this -0.5, right? So one of them will build 90 degree, so would be this line. The other one will make 270 degrees, which is going to be this line, same line. So they're just on top of each other, right? So 270 is -90. You could say -90. When you're drawing, you do whatever works best for you, but your calculation, you have to follow these equations. So now what should I do? What does it mean? This pole at -1 has to go to infinity alongside an asymptote to find its 0. There's an asymptote right to the left of it. You know that the Locus has to be on the left side of the odd number of the poles. Whoa, what happened? So this guy will go here. Then again, for the -2, the Locus still have to be on the left side of the odd number. So still has to be between -1 and -2, right? Cannot be here. It has to be on the left side. Has to be in this area. So since we have one asymptote over there, this is gonna go to infinity along this one. Yes. just draw. Yeah. So the left side has to be on the left side. I start with the far left, far right, goes to the left. Yeah. Did you have a question?
No.
No. Thanks for the news. Make sense? All right, so let's draw root locus for this guy, for this transfer function. So here, you have the characteristic equation. That's the G of S, which is already, this is when I say characteristic equation, this is G of S, so you don't have to do anything. This is pretty much the summation of whatever I just talked, just the numbers are different. So draw is the same thing, it's just the pole, location of pole and zero are different. Draw root locus for this, everyone. So find N, M, number of lock keys, put the poles and zeros. Is something wrong? Everybody's looking weird today.
Those are the same poles, right?
Oh, you know what happened? Because I changed it here to -3 and -5 here. In the annotated version, I used 3 and 5 for that example, and then I kept it. The idea is the same thing. I wanted you to use similar examples, solve similar example, but everything from top to bottom yourself. Central value will be different, but similar kind of. Why can't? Where does it say math at? Homework 5 is going to be a project, and you're going to have an interview with me. So I'll see everyone at least one in person in my office. How cool is that? Depending on your definition of cool, you might right.
Very chance, good job.
Like help me to find a job, yes. Depending on how good you are. Okay. Okay, quick. You're still writing the question. You need to start writing the solution. And then I need to know what is this. All right. And 2 and 0, number of Walkie, it's 2. Poles are at -3 and -5. I'm gonna draw to see what do I need. So pole at -3 and -5. So I know based on all the rules, I need 2 Lockies, same story as the previous example, but these both of them will go to infinity. They need their own asymptote. Now you need the centroid. What's the value for centroid that you found? So sigma A is -3 plus -5 minus 0 divided by 2 minus 0, -4. So we are gonna have an asymptote that will pass through here. PA1 is 2 times, well, Q is going to be, help me with Q. So Q is 0 and 1. Since we already done that in the previous example, this one gonna be 90 degrees. PA2 is 270 degrees. So same deal. So you could, since you know on top of each other, you could draw half of them, and then you can say that, well, this has to go on its own. So if you want to put negative infinity here, just, you know, show that you know what's going on. So now, based on this, like when we talk about centroid, so if you think of poles, they have gravity, they have, okay? The centroid is the center of gravity of all the poles. Right? So you could, if you wanted to just just guess how this looks like, and you didn't want to do calculation, you say, okay, these two are here. About this area is the center of them. I know that the two will go about an asymptote around that middle section. All right. So you could easily guess how a root locus would look like. Now, is this system stable or unstable? Stable, right? So if you were to design a controller for all the case that will place the poles in either of those two loci, the system will remain stable. So it just makes you feel better. Okay, doesn't matter what K I choose, my system is not going to be unstable. This is a huge information. So you can then forget this and then go and check only the system response. Now I have, yes, okay, no, we need one more thing. All right. Because I'm going to show you the root locus full screen for another example. All right. So sometimes they are more complicated, like the one that you did in your class participation, right? They're like kind of curved and whatnot. So how do we know those shapes? So if you need a little bit more information, I'll give you one more just to give you an idea, but then we'll stop there and we only will use MATLAB. All right. So if my transfer function g of s was 1 over s plus 1 over s plus 2 over s plus 3. All right. So what would this root locus look like? So -1, -2, -3, n is 3, m is 0, number of loci is 3. All right. I know that I need 3 asymptote, correct? There's no 0, all 3 of them have to go to infinity. Now, how do they go? They could go along a 90 degree up or down, or there could be other shapes, all right? So here, like calculating asymptote is more important, but the thing is, if you learn how 3 poles without 0 root locus would look like, then you have the shape. They just move based on where their poles are, right? So Q is n minus 1, 3 minus 0 minus 1 is 2. So you have Q0, 1, and 2. Now, if you calculate the angles, put it in the equation, one would be 60 degrees, PA1, PA2 would be 180 degrees, then your other phi, A3, let's call it, is going to be 300. I just used those equations. This in the annotated version, I have all of it. This is just to be faster. So next thing, I need to find my centroid, sigma A. Sigma A is 1 plus -2 plus -3 minus 0 divided by 3 minus 0. This is going to be -6/3, -2. So this tells me that here is also sigma A, the centroid of the asymptotes. All right. So I know that one of the asymptote has 60-degree angle, one has 180, the other one has 300. So this is the 60-degree angle. This is your 300. And then let's use this. This is going to be your 180. All right. So now this is the choice that, okay, now which one goes along which asymptote? We have one more piece of information. The log key will be on the left side of the odd numbers, right? Of the poles or zeros. So this one is the first one. This is the second one. This is the third one. So I know one log key is going to be in this area. One log key is going to be in this area. So this tells me that this third pole has an asymptote of 180. So the log key is also on that side. So we can say this log key will go here to infinity. So we figured one out, right? So we only have the other two asymptote, and the log key has to be between -1 and -2, right? So these two have to go along these two asymptote that are building like an angle. So we know that they will start on the real axis. Now, where do they go out? There is another piece of information. It's called breakaway point. So if you have read your books or other textbook, you'll see breakaway or break-in points, meaning that where does the log key departures the real axis? Because the log key has to start from the pole, right? So we need a location where to depart. Because here, it has to start here and then it's going there, right? So maybe it's going this way. We need to figure that out. The equation is you will put bless you. K equal to -1/GS coming from 1 plus KGS equal to 0, right? Then this would be -D of S, N of S. So the numerator is D of S, the denominator is N of S. You'll have to solve an equation to find those values. NS times D prime S minus N prime S times DS. This looks complicated, but a lot of time, and there's no zero is 0. So you only have to solve one side of the equation. If you find the roots of this equation, the root that is between the acceptable area would be your breakaway point. So let's solve that for our example. What is D of S for our example? What's the numerator of our G of S? 1. NS is going to be, well, you have to, now here is a little bit of calculation because you have to write this down in terms of the polynomial. I have solved this. Let's see, let's do it together very quickly. Is there a smarter person between us than me that can do this quickly? 3 plus 3s squared plus 2s squared plus 6s plus 2s plus 6. All right, I solved it. 3 plus 8s squared plus 8 s plus 6. Cool. All right, found it. Now all I have to do is n times d prime, and then so n is this huge thing times d prime is 0, then minus n prime times d is 1 times n prime 3s squared plus 16s. I made a mistake here because my solution was different. This will give you some s equal to, let me quickly cheat because I have it here. Just going to use that. S is going to be either negative 142 or 257. I made it negative 1.42 or negative 2.67. So this one is not quite right, but let's say. So these are our two S's. Which one of these two are between negative 1 and negative 2? This one, right? So not all the roots of this equation going to be the breakaway point. You have to look which one would make sense. There's always one of them. So I know my breakaway point is going to be negative 1.42. So now I can draw this guy. Then this has to go here. Now, how would you know? You had to see it or use all the other information about root locus that I didn't give you. So here is where we go and plot using MATLAB and check. Did we find the centroid correctly? Did we find our breakaway point correctly? All right. So for the part that is by hand and manual, I would just ask you to calculate a few things. Then you go to MATLAB and just confirm those values were correct. All right. Let's say you want to practice another one. You can say 1 over s times s plus 1 times s plus 2. The shape will be similar. This just will be shifted. So that will be a really good example for you to do at home, for example. All right. Now, let's say we have 10 minutes. Go do your class participation. It's basically doing the same thing. You have to calculate all of them, and then you already saw the solution, right? You kind of know how it looks like. Yes. So we know that the log key has to be negative 1 and 2 because it has to be on the left of the odd number. So negative 261 is on the left side of the second. That we cannot. Question? No? So what you're doing right now is to basically finish up this one, the previous example. Nope. This one. So you already calculated this. So I gave you the same thing, so you don't have to find your N and S, you already have them. Just answer this question and try to approximate it. You already saw how it looks like. So put this, don't forget, put this in the correct form and then go from there. Let's see. Yeah, n is the numerator, d is the denominator. Yeah. Okay. Sharing. You need a passcode. Okay, I think I made a tiny mistake. Gonna fix that. It does not impact you for now. So this is n, this is d. So d denominator and numerator, even though I wrote it there, I don't know why I did it backwards here. Okay. N is 1d, yeah, that. So you would not end up with a negative number. That's all. Passcode.